by these four parameters, A, B, C, and D. So let's look at how those different parameters affect the function. First of all, I want you to notice that two of the parameters are outside the function, A and C, one multiplication and one addition. Those affect the vertical direction of the graph, or they cause a change in y. So anything outside the function affects y. B and D, however, are inside the function, or inside what's called the argument of the function. They affect the horizontal direction of the graph, or they cause a change in x. Now let's look at addition and subtraction first. What happens when we change C? C causes the graph to either shift completely up or down from the sinusoidal axis. So C actually is the sinusoidal axis, because if the entire graph shifts up 2, then the sinusoidal axis changes from 0 to 2. Notice that the graph doesn't change at all when the shape and the size of the graph doesn't change at all when it shifts up and down. D causes the graph to shift right and left. That actually changes the phase displacement. So instead of starting at 0, if the graph shifted to the right, maybe it would start at 2. Or if it shifted to the left, it would start at -3. Interestingly enough, when we subtract, when we say x minus 3, the phase displacement actually becomes 3. And when we say x plus 3, the phase displacement becomes -3. In other words, when we add a number, it shifts left. When we subtract, it shifts right. Now when we look at the next two parameters, B and A, those are both multiplied. Outside the function, we have A. When we multiply by A, in other words, A is greater than 1, the amplitude increases, it becomes taller. So A is the amplitude of the graph. When we divide by A, or when A multiplied by a number less than 1, the graph becomes shorter. This horizontal line x represents the sinusoidal axis. The graph stretches up and down by a factor of A from the sinusoidal axis. If A is less than 0, then the graph reflects across the sinusoidal axis. In other words, it flips over. So instead of cosine starting high and ending high, if A were negative, the cycle would start low, go up to a high point, and then end low. Because we're stretching away from the sinusoidal axis, points on the sinusoidal axis, the x-intercepts in this case, would not change. If the sinusoidal axis was something other than the x-axis, it would be points on the sinusoidal axis that would not change. Now let's take a look at B. B is inside the argument. It affects the x direction. B is not the period. We have C as the sinusoidal axis, D is the phase displacement, A is the amplitude. Our fourth characteristic is period, but B is not the period. B affects the period. B is 2 pi divided by the period, or the period is 2 pi divided by B. If we multiply by B, in other words, B is greater than 1, the graph actually becomes narrower, because 2 pi divided by B is the new period. If we divide by B, or multiply by a number less than 1, the graph actually becomes wider, because 2 pi divided by a number greater than 1 makes the period smaller. I'm sorry, 2 pi divided by a number less than 1 makes the period bigger. So if you do 2 pi divided by 1/2, the period would become 4 pi. If you do 2 pi divided by 2, the period would become 1 pi. What does not change? Well, since the graph is stretching horizontally, it's stretching away from the y-axis in both directions, so the y-intercept doesn't change. So to summarize, how can we remember these transformations? Anything outside the function affects the vertical direction, or y. Anything inside the function, in the argument of the function, affects the horizontal direction, or x. Furthermore, things outside the function, A and C, affect the graph in the expected way. When we add, the graph goes up. When we subtract, the graph goes down. When we multiply, the graph gets taller. When we divide, the graph gets shorter. However, B and D, the things inside the function that affect the x direction, affect the graph in the opposite way than we'd expect. When we add, it shifts the graph to the left. When we subtract, it shifts the graph to the right. When we multiply, it makes it narrower. When we divide, it makes it wider. So there's a summary. Make sure that you think through and know these very well, because these characteristics not only apply to sinusoidal functions, they apply to all functions.